Hello and welcome to the Virtual Eclipse Community Meetup. I'm your host, Kat Hirsch, and today is the 5th day of the Eclipse Oxygen webinar series. Today also happens to be a very special day for the Eclipse community, as we have just successfully shipped the 12th annual simultaneous release, Eclipse Oxygen. Head over to eclipse.org/oxygen to download your copy and to learn what's in store with this release. So for today's presentation, we will be going through generic editor and language server protocol with Mikhail Istria and Sopot Sila, and we will reserve 5 minutes at the end of the presentation to go through any questions you may have. Simply add a comment to the YouTube live event chat box and I will relay those questions to our presenters at the end. So without further ado, I'll turn the stage over to Sopot and Mikhail, and we hope you enjoy the presentation.
Today we'll be talking about the generic text editor, something that we actually put into the new release of Eclipse, which, as Kat mentioned, is going to be today. So first, a couple of words for myself. So my name is Sopot Sila. I'm a senior software engineer working for Red Hat on the Eclipse products. And yeah, my work is mainly as a committer on the platform projects like Platform UI, Platform Text, which is the editor part, and various other things. And something that we've been working for this last release is what we call the generic text editor. And of course, you would ask, what is that? What is the generic text editor? As you can see there, it's basically a text editor which you can extend. That's why it's called generic. So in itself, the basis of it is really a simple text editor, just like Notepad. But you can extend it, and what we mean by that is that you can teach it to provide syntax highlighting, for example, patch files. And you can also teach it to provide autocompletion, as I will show you for target files, or what we call target definition files or target platform files in Eclipse. And you can do many other things like Hoover and things like this, but this is basically the philosophy of it. This is what this generic text editor is. Another thing is that it's easier to extend this generic text editor than to create a brand new editor in Eclipse, especially if you want basic support. I mean, I always say this when I explain this to people what it is. It's basically thinking of Notepad++. I'm not sure if you know it, but it's a pretty popular, simple editor for languages. And this is a similar idea. So you have relatively basic support for multiple languages, and it's much easier to do it now with the generic text editor than actually going and creating the generic editor from scratch. So as I was mentioning, this is the reasons why we need this, because it's easier and faster to produce support for new languages. So we've already tried this, and we'll talk about it a bit later. We've already tried this for some languages. So another thing is that it makes it possible to quickly consume multiple language server protocols, and this is something that Mikhail will talk about in the second part of this. It allows the decoupling of the editor infrastructure code, which is basically the boilerplate code that you need for building a text editor. There is a lot of that wiring and that kind of stuff that needs to be coded in when you make support for a new language, and just part of it then is like the actual business logic of the language processing, like making syntax trees or whatever you need for providing that support. So this makes it easier because it basically does most of the boilerplate for you, and then allows you to basically just do only the language processing part. Another point that I want to make clear is that this is not a replacing of the way that Eclipse does editor support. I mean, of course, there is this is just an additional way of developing editors. There's the existing infrastructure of building well, not old, but the already existing editors, like the Java ones, which are fairly mature. They're still there. They're still going to be there, of course, for a long time. But now you have an alternative, which in some scenarios, and that is mostly building basic to medium support, is much faster to develop because much of the boilerplate is out of your way. Now, if you want to really go into very, very specific and deep diving support for languages, then you might consider whether this is the right approach or not. Now, I'll get into the technicalities a bit. How does this work? This works with extension points, and yeah, supposing you're familiar with what an extension point is, but if you want to develop a plugin in Eclipse, there is this thing called plugin.xml, and this is where you put your extensions, which is basically you hook your logic and call it an extension. So for example, you say that I want to provide some presentation code for this language. That would be the syntax highlighting part, or autocompletion, or hover, or whatever information you want. And you put this through the extension point mechanism. And the way that you declare, so this extension point is for this, and that language is via content types. This is how we've decided to do it. I'll show it to you in a bit, what how this actually looks like. So okay, before I go to the demos, I wanted to mention that we're actually already dogfooding this for Eclipse, because it was also when we talked with the leadership of the project for making this this change in the core of the Eclipse editor infrastructure, we decided that we really need to use this ourselves for some cases, which are like not really languages. Like you can say, for example, the patch editor. You see the patch format. It has its own, like it has pluses, it has minuses. You can't really call it a language, but for this kind of things, we have already started to provide editors within Eclipse in this Oxygen release that use the generic editor infrastructure, and that was also an exercise to consume it and see where its potential flaws are, and it has helped us a lot. So we have been using it for a while now in our testing of Eclipse, and now, starting from today, it's also available. It's the Diff and Patch editor in Eclipse. It's a platform team project, and the Target platform editor. This was quite popular, I think, because many people are have issues, let's put it like that, with the default Target platform editor in Eclipse, and then they see some issues. And I have provided textual generic editor, or an extension to the generic editor, to make use of autocompletion and syntax highlighting for target files, which we will look at it in the moment. And also in the Linux Tools project, there are various editors which have already started to use this. So this was just to make sure that you see that this is not some pie in the sky project. This is actually being used within Eclipse today, and it has the power to be used more and more as we progress through the technology. I think that's pretty much it for the talking part. So I will, in the demo, we will be looking at two things. We will first be looking at these two points here, the Diff and Patch editor, how it looks, and the Target platform editor, how it looks. And then for those that are very technically minded, I will spend a couple of minutes in showing to you how these are actually developed, and what I mean by the fact that it is relatively easier to develop these with this generic editor infrastructure rather than with the old or previous way of doing an editor from scratch. So let me switch to my clips. Okay. So supposedly you can see my screen. If not, interrupt me, please. So this is a simple diff file. These two are some diff files. And normally in Eclipse, you don't have an editor for it. So if you open it if you double click on it, you will see this really like basic. This is basically a notepad. This is the default text editor in Eclipse. And you see there's actually no formatting. It's just nothing. It's just line numbers. So we have built by using the generic editor infrastructure, we have built an extension to the generic text editor. So you can see this is only one editor, and you plug in extensions to it. So this is not multiple editors for multiple content types. This is just one text editor, and we provide extensions to it. So if you do an open with on the diff file, then you select generic text editor, and then you see this, which is progress from what I showed previously. So you see here there are these rules, like diff and index has a certain color and it's in bold, and if it starts with this chunks, the patch chunks, it has a different color, and the minuses and the pluses are red and green, and then the header is also shown in a different color to make it more visible. So this is a case where we only have syntax highlighting. We don't provide for the moment any kind of auto-completion, because also it defeats the purpose for a diff file. I don't think there is much use in starting to edit and modify diff files, because it can go wrong really fast. So for now, that's all we have on the syntax highlighting on the diff and patch files, but it's already progress, and this took me relatively short time to build. Another thing which is a bit more fully, let's say, featured is the target editor. So you're probably familiar with this kind of files if you develop plugins or RCP applications in Eclipse. And this target definition file, that's the official name of it, the target definition file, or also called the target platform file. You can also do the same here. You can open it with the target editor, which is the previous one, but right now we also provide this extra extension to the generic text editor. As I said, it's the same editor, it just has two extensions. Now, if you click this, then you will see this, which is a bit of a different way of looking at the target editor. You see the target definition file, you see it's basically an XML. So you see this header of the XML, and then you have the tags, the properties, the attributes, and then the attributes and attribute values. And this is not just, for example, you see also the comments have this different color, the green color. So this is a case where it's not only syntax highlighting part, but it's also auto-completion. So for example, here in the version, I pressed the control space, and you see it's going into the P2 site here. It's a big file, but it's going into the repository location here, P2 repository of Orbit, and it's picking the versions, and it's proposing you that, yeah, you can choose either of this and also the generic version here. But also, it also works with the unit ID. This unit ID is basically the jars or plugins, you could call them. The unit stands for the installable unit concept in P2, but it's basically what you have in the Orbit site. So you can say, I don't want this guy, but I want this guy. Say jdump source, and then it will change the unit ID for you. So this is also something which is which was done by the generic text editor infrastructure, and that's quite helpful for people that are editing target definition files. I think for now that's so. Yeah, of course it has also tag support into the XML and also attribute support. So you build your own. You can type your target platform file or target definition file, and it will help you on the way. So this is as far as the features go. Like, I will quickly show you also how this looks in terms of development. So you see these two projects here. These guys are the actual projects that are providing this functionality. So I imported this from within Eclipse. And this is the actual code. Let's say this is the code for providing this support, like the diff support. And then if you go here, you see you have this plugin.xml that I told you about a bit earlier. And then you have this presentation reconciler, which actually has the code. So this is where you hook it and you say, yeah, for this content type, which is the patch or diff, and that is meaning if the file ends in patch or if the file ends in diff, then you hook this presentation reconciler. And the presentation reconciler is nothing more than a Java file. And this is the whole thing. This is why I also mentioned that it's relatively easier to do it. And this has just a bunch of JFace text rules. And it's saying, this is a start of line, which is a small customization, but it's really easy. It says if it starts with commit, and I don't care what it ends with, then it's the header attribute, and then the header attribute just make it a magenta, dark magenta color. And the same with this guy. If it starts with 3 pluses or 1 plus, then it's a body attribute plus, which means you will see these green colors. So this is enough. With some other, like this thing is really small, this start of line rule, and this is relatively easier compared to having to create your own editor from scratch. You just get your plugin XML, you provide an extension, you say this is the content type, so what kind of file you want this for, and then you actually go and type the code, which usually extends presentation reconciler, but I'm not going to go into those technical details of how these methods work, because that's basically out of the scope here. So yeah, I think that's as far as the diff goes. The same goes for the target, the PDE target platform editor or target definition one. So this is a bit more complex because it has auto completion and all that, but I'll also show you quickly the presentation reconciler. So this is for the presentation reconciler, which is basically a fancy name for the syntax highlighting code, and it's the same here. So this is for the header. If it starts with this and ends with question mark, so this is the tags, this character and the question mark, then that means it's a header, and the header means that the color is gray, and that's all you need for having basically this part here, the gray XML. And the same, if it starts with this thing, then it's a comment, so make it green. Like give it the comment attribute, and then the comment attribute means make it the color dark green, and then you have this guy. So this is what we thought of making this simpler way of doing editors or providing support for editors, as I said. So for example, in this case, it's relatively basic, and it's much faster to do it like this than to start from scratch. So I think for me, that's pretty much it as far as the demo goes. So I'll switch back to my slides, and I'll make the transition here to Mikel. So there is the only thing I'm going to say before I switch off is that this, as I mentioned, this boilerplate code is now separate from the logic, and that means that this logic can now come from anything, including something that is called the language server. So that's going to be quite helpful in the future, and we're already doing quite a lot of things there, for which Mikel will talk about it now for you. So I'll stop my sharing, and yeah, over to you, Mikel.
Okay. I'm going to present about the language server. I will use this slide deck. Can I put them full screen with the video started? Okay. So about language server, I'll go in a lot of details. So before we get started, I would like to clarify a few terms we'll be using in the next 20-something minutes. First, when we talk about language in the context of language server protocol, it's only textual languages, which mean that graphical languages such as diagram, which are very popular in our community, are not currently in the scope of the protocol. So it's only textual languages. Those languages do not necessarily require a grammar or clear definition. They can be ad hoc languages as long as there is a way to extract smartness from the text document, from the textual language. It can be considered as a language, so you don't necessarily need a schema. If you think, for example, about the diff file, Sopa just saw there was no schema, it was all inferred from the file. And in the context of language server, a server is not necessarily a web server or a remote server. What we mean by server is any application that provides a service according to a contract, which is the language server protocol. So a server is not necessarily a remote server, it's whatever application. The current state of art of integrating a language into a tool is that the developer who does that end-to-end have to know a lot about the language and the technical stack that involve the language in which the language itself is written, the APIs, the parser, and so on. And the developer also has to know a lot about the tool they are targeting. So for example, if you want to introduce a language in Eclipse IDE, you have to be very skilled in Eclipse IDE metaphors and APIs. And if you want to do the same in VS Code, you have to be very skilled about VS Code and so on. So it requires developers who have a lot of skill in the language and in the tool. Those are not very frequent. And the current difficulty of integrating a language with a tool end-to-end is 3 abstract work units. And how does that scale? Currently, if you integrate language and tools one by one, you end up with a matrix-based integration, which has a complexity of m times n, if m is the number of languages and n the number of tools. And if we take a subset of all the languages and all the tools supported by language servers, we can see that if we have 8 languages and 6 tools, or 7 tools, 7, we get 120 abstract work units. So the scaling of this integration type is not very good. And moreover, it is both caused and the consequence of such integration not being designed for separation of concerns and reusability. So if you look at how an integration is done, if you taking JDT as example, there is not much effort in putting the Java logic, the Java completion and so on, separated from the Eclipse UI logic. So with this strong coupling, it makes it hard to reuse and to separate concerns. And that's the purpose of the language server protocol. So the language, the language server protocol is a protocol which is language and tools agnostic. That's the very important point. Since it is agnostic from any tool and any language, it makes it universal to all tools and languages. And you should see the language server protocol as an interface between the language logic and the tool. So what happened is that a language server will implement the protocol, will be a server for the contract. And this language server contains all the logic related to the language or the framework. The language server doesn't directly interact with the tool. It doesn't know which tool it's targeting. So it makes that the goal of this language server is very focused on the language logic. And the tool simply consumes the protocol with the protocol is actually an API. And the tool simply consumes the protocol to send, to request smartness from the language server as messages, as we'll saw just after. The difficulty of this integration, since there is a clear separation between the language part and the tool part, it makes that the difficulty, the effort can be easily splitted into parts. One which will be for language experts and the other one which will be for tool experts. So being able to split this work and to distribute it among different kind of expertise is a very comfortable thing. Some insights about the protocol and history. It was initiated as part of Visual Studio Code by former Eclipse IDE contributors. And when I say contributors, they are kind of authors, the first contributors to the Eclipse IDE. It's open source on GitHub and it is community aware in the sense that they really take feedback seriously, they welcome pull requests and so on, but there is no clear governance about what can be merged and when, because it's still owned by the team. So it's not fully community driven, but it's community aware, which is a great thing. The protocol is based on, it's simply a client server with a request response or notification. And those requests and response are using the JSON RPC protocol for marshalling of messages, which happens to be language agnostic. So whichever programming language you're using, you will be able to create a JSON RPC layer to send requests, response, notifications, and so on. A very cool thing about this protocol is that the transport for the message is not constrained. You just have to communicate via streams, regular streams, input, output streams, but the streams can be anything. They can be in-memory streams in the same process. They can be stdio in your operating system. They can be IPC, which is widely used in the Node.js environment. They can be UDP streams. They can be WebSocket. So you are free to choose the best way to communicate with the language server as long as it's speaking the right JSON RPC messages. And since the transport is not constrained, the deployment is not constrained neither. So if you think about how Eclipse IDE can consume a language server, it can decide to create a local thread with the language logic and interact with this thread via input and output streams. It can be a local process on the same machine. It can be a local process on a Docker image. It can be a remote connection to a remote server. So the deployment is not constrained, and that opens the way that opens the path to many ways of distributing your language server. So the lack of constraint makes it very useful in many cases. One key factor of success of this protocol is that the operations it provides map very well the needs of a text editor. This is mainly caused by the strong experience of the ones doing this protocol. So if you look at some of the operations on the right, you see that they map things such as completion, hover, references, which are typical things of any editor. They have workspace/symbol, which would be like OpenType in JDT. So the mapping with the existing interfaces and the existing features of any editor is very strong, and implementing this mapping between the tool and the language server is relatively easy. So the clients simply connect to the language server, as I already explained, getting an input and output stream. It may involve starting the language server. As I told before, the deployment is free as well. So, and the life cycle is free as well. So the tool can start its language server instance just for itself, or it can decide to connect to an existing instance. It's really up to the integrator to find out what's best for their use case. But the clients already offer a lot. And then the client orchestrates request and read, response, and notification over JSON RPC. We'll go into more details with that a bit later. An example of communication with JSON RPC. On the left, you have the request, which is sent from the tool to the language server. So the request is plain JSON RPC. You see a method, param, and so on. And on the right, you get the response, which is, again, a simple JSON RPC message. So all that is easy to use with any language. You can write a parser for this in Java, in JavaScript, in TypeScript, in OCaml. So that's a reason why the protocol is successful, because it uses layers which are not language specific. How does this approach scale? So it turns the matrix-based integration into a star. Since the language server protocol is in the middle, tools and languages only have to integrate with the protocol, and just with that, they provide all the value of a good developer experience in an IDE. So the cost, the estimation of the cost will be M plus N instead of M times N, which would resolve to 32 abstract work units in our examples. And the very cool thing, as opposed to the previous integration, is that the language server protocol is designed for separation of concerns, which makes it easier to distribute work across teams. and also to reuse it from one tool to the other or from one language server to the other. A nice thing is that since every tool would implement integration with the language server protocol only once, for example, Eclipse IDE has one integration with the language server protocol, and then you can plug language server very easily. We'll show it later. Since a tool connects only once with the protocol, there is no need to copy past features from one language to another, and then it brings a lot more consistency to the editor experience, because you don't have to repeat the same commands, you don't have to repeat the same UIs and so on. So this consistency is very profitable for users who can easily switch from one language to the other and keep all their shortcuts and features very similar. There are SDKs for the language server. What we call SDKs are libraries for a specific programming language to easily create a language server or a language server client. What they do is that they usually they create interfaces and objects that are easily transformed into JSON RPC messages for the language server. And the SDKs deal with the connection part, deal with the messaging part. Messaging means matching the response for a given request. They deal with the marshalling and the unmarshalling between JSON RPC and your language. And in the Java world and in the Eclipse world, the SDK is Eclipse LSP4j, which has a very strong and good coverage of all protocol features, and which is very nice to use. So if you're interested in doing Java-based language server, you should look at this API. The benefits for the Eclipse technologies and ecosystem are obvious. Existing programming language and language-related technologies can implement the language server protocol. So by implementing the protocol, it makes it easier for many tools to consume it through the protocol. So if you create a Ceylon-based language server for Ceylon, then you can plug it to Eclipse IDE, which support the language server protocol. You can plug it to VS Code, which support the language server protocol, GNOME Builder, and so on. So you distribute your language tools on many tools at once. Same thing for everything that's related to static analysis, linting, and so on. And all the various IDEs we have in our community can obviously be clients of the language server protocol to easily support many language servers with very minimal integration effort. In the Eclipse IDE, more particularly, the project that binds Eclipse IDE with language servers is called LSP4E. So it makes Eclipse IDE able to consume language servers. And it is part of the Oxygen simultaneous release we are celebrating today. And it is based on extensions to the generic editors that Sopot just presented. And so, for example, the completion is an extension to the generic editor, just like the completion for content assist in the .target file. And so editor-specific operations are bound to generic editor, and other operations such as outline or search are bound to typical Eclipse views and commands. The flow as a user and as an integrator is that the user will request the generic editor for something like completion. The generic editor would forward this request to LSP4E, which registered extensions to the generic editor. LSP4E would request LSP4G, which is the plain Java API to deal with language server. And LSP4G would send the request conforming to the language server protocol, which means it will deal with serialization to JSON RPC and so on. It sends the request to the language server. The language server processes the request. It's a black box. We don't know how it processes it, but we don't care. And the language server gives the response, still speaking JSON RPC and so on. And LSP4j will turn it into nice Java objects, which are easy to use. LSP4e will turn those nice Java objects into nice JFS objects, which are expected by the generic editor. And the generic editor renders, in that case, the completion list to the user, who is very happy. The demo. So here is a video demo of Acute. Acute is a plugin for Eclipse IDE to deal with C# development. In the plugin.xml of Acute, we see some extensions to define the language server. In that case, the language server we use is called OmniSharp, which is typical for C#. And the only thing you have to do is to implement the stream connection provider interface, which has three methods: start, get input stream, and get output stream. As I told you, the stream are very important. Start is because in that case, we do start one language server instance as a process to interact with. So we deal with the life cycle of the server. And then we associate this language server with the content type of C#. So it's been kind of easy. There are only three methods to implement and one binding to do. And let's start it. Nice play screen. Okay, here we are in a C# editor. Just a note, the syntax coloration is provided by Textmate, not by language server. So we can see this C# file, and the first metaphor we see, which is visible, are the diagnostics, the problems, as we call them in the Eclipse IDE. Those are provided by the language server, by OmniSharp, and they are rendered in the IDE as usual, in the problems view, in test.ca, in the project explorer, and so on. Here we could see completion in action. Same thing. The completion just asks the language server for proposal and their return. The hover is the same. So here I hover, and it is LSP for you, which sends the hover request and retrieve it and shows the result. The find references command, typical command of any programming language. Here you have the control click, which is being shown. Jump to declaration, control click. Next will be, I will modify a bit the code to show that diagnostics get updated. So if I remove a line, I see the warning is removed. If I remove the error is removed, just as usual with any Eclipse editor. And to get all that, I didn't implement anything C# specific. I didn't write any C# parser. I didn't do anything C#y. I just asked OmniSharp for the result thanks to LSP4e. So what we'll do is that we'll show the messages produced by the language server interaction. So let's ask for hover on right line, and we'll see the messages. So we ask for hover. If we scroll up, we can see this nice JSON RPC message, which do ask the language server for hover. So it's method hover on test.cs line 4, column 21. And a bit later, we get the response from the language server, which is for your request number 60, the ID, it is the hover one. Here is what you should show to your user. And that's as simple as shown here. All the magic is to properly integrate it in the IDE, to properly orchestrate the request, but there is nothing more. And another example is for notifications. I've removed one of the diagnostics, one of the erroneous line, and we can see the notification message with published diagnostics, which sends updated diagnostics. So we only keep the ones about the erroneous line number 7, and so on. Let's see more feature of the language server protocol. First one is a JSON editor from the language server is VS Code. It's also doing schema validation, and the nice thing it provides, which OmniSharp doesn't provide, is an outline. So the outline is part of the protocol and it's very handy, and good language servers do give the outline. And another one is the CSS language server from VS Code as well. And what I want to show here are the quick fix. So you don't only get diagnostics, you also get quick fix to make resolutions, such as replacing call by color. And here it is the HTML language server from VS Code still. And the very cool thing is that this language server has support for embedded completion and hover inside HTML for CSS and JS. So if I ask for completion in this JS code block, it gives me the available JavaScript method, and So I can be very efficient at doing web development with this language server. The demo is ongoing, but the interesting thing, again, I want to repeat it, is that to get this working, I only implemented one method to start the language server and two methods to connect to the input and output stream, but there is nothing that does parsing nor code analysis in my plugin. All that is done by the language server and is provided for free, and all I have to do is to connect to this language server. So that's all for the demo. Let's get back to the slides. So the projects I showed you are Acute, which is on GitHub, and Blue Sky, which is on GitHub as well. The first one is about C#, and the other one is about web-based development using mainly the VS Code language server. Again, the collaboration was provided by Textmate and TM4E project. We will probably make those projects part of the Eclipse.org ecosystem very soon. Other possible language. So I told you multiple times the language server is successful, but I didn't give you metrics. A very interesting one is that 27 programming languages have announced LSP support this day. The protocol is about 1 year old, maybe a bit less, and already 27 very serious languages have adopted it, which means that Eclipse can easily connect to any of these 27 language servers to support any of those 27 languages. And the list is growing weekly. Now, a bit more about the limitations of the LSP, because it's great, but as everything, it has to have some limitation. And the first one is that it is focused on edition only, edition time. So the testing, debugging, running the application is totally out of the scope of the protocol at this moment. And it will most likely be a topic for new protocol, because the cool thing is to not mix them too much. The language server protocol is missing some important operations as part of its API. Mostly the one I miss the most are type hierarchy, which are very important for us as Java developers, and also refactorings. So the only refactoring which is well supported is rename, but we can think of many others that could be did the same way, and there are issues on this topic on the GitHub of the protocol. As I repeated already 3 times, I guess, syntax highlighting is not part of the protocol. It is provided by Textmate grammars, and the Eclipse TM4E projects takes care of rendering the text with syntax highlighting. The TM4E project is also an extension to the generic editor. What it does is Sopot showed you a presentation reconciler which uses regex and so on. TM4E basically creates a presentation reconciler which uses a Textmate grammar and plugs it to the generic editor. So it's still very related to the generic editor. And the other part to be discussed for language servers in general is how to compose them. So that's a hot topic, currently not a critical one, but let's assume you have multiple language servers that can help you for language. How do you want them to mix? Should they aggregate, so you see results from both of them? Should one of them replace the other? Are they competing or conflicting? That's currently a tricky question that is still not part of the protocol. It is part of the integrators' decisions when they deal with language servers. So for the future of the language server protocol, here are the 2 things I would like to see resolved in the next 6 months. I'm not the one who decides what gets resolved, but I will try to lobby at least. One is support for refactorings and type hierarchy, and the one is to initiate a proper debug protocol that works just as well as the language server protocol, but for debug. And that will also support running applications and also test notifications. Yeah, all the stacks I've shown you are open source. Most of them are in the Eclipse world, so feel free to join the LSP game. And that is all for me. Back to you, Kat.
Thank you, Mikhail. Can everyone hear me okay? We'll assume I can be heard okay. Great. So we now have time to do a quick Q&A. We did receive a lot of great questions throughout this presentation, so I do want to share those with you now. So bear with me here, I open it up. So the first question received was from Lorenzo, and he asked, what if you want properties that the user can change for syntax highlighting? Can you easily somehow connect styles with properties, or do you deal with properties yourself, for example, with standard API?
Yeah, well, I can say I fully understand what is meant by properties in this context, but I can say that for now we use the standard APIs that you have in, let's say, the JFace text properties or the rules. They're called rules if we want to get technical, and these rules you have to provide. You can of course customize them, but for now, I mean, if you want specific styles or an external source where to get them from, then you have to implement them yourself. But right now we're using the JFace APIs, JFace text APIs, like a single line, multiple line, regex rules, or whatever is offered in that layer. So I'm not sure if you want to add anything, Mikhail.
No, I don't have anything to add. Maybe you mentioned several times that we are using JFace API only in the generic editor. That's actually an important choice, which makes that the code you've written for other editors, specialized editor, can be migrated as easily to the generic editor. There is no new concept for you to adopt in order to migrate your code, since we are fully relying on JFace. I'm not sure it answers the question.
That's also how the Linux tools people did their editors. They basically migrated part of them and copied their rules into the generic editor just to have that more tidy. So yeah, I think there's another question from. I can go ahead, Kat, if you want.
Yep, go ahead.
So it's about whether we can create a new editor by extending this guy, and I don't think that's the plan that we have in mind for this kind of editor. So the way that we thought is that you extend the functionality through the extension points rather than subclassing it and creating it, let's call it a specific generic editor for something else. So, I mean, of course, you could do it if you get a bit naughty, but that's our idea of it, that this thing. Of course, there could be improvements in the infrastructure itself, but if you want to specify behaviors or to teach behaviors, then you'll have to do it through the extension points, not by extending it itself and making a special generic editor.
Yeah, it's an important point. I think we try to be strict at this moment on the topic of generic editor, is to keep it generic. And Lorenzo, if you want things that are missing in the generic editor, at the moment, the only nice way to have them is to contribute to the generic editor. And we are closing a bit the ability to do inheritance and so on, to really bring people in implementing generic ways and extension points and so on, which are the holy grail of editors. So at the moment, inheriting from the generic editor is between impossible and not recommended.
Okay.
Mikhail, can you take the next one?
Yeah, so I'll read that one out for you. So
okay.
Where can we find a list of LSP supported languages for Eclipse Oxygen?
So in Eclipse Oxygen, LSP4E has been kind of new, and we didn't put into Oxygen language support directly because it wasn't mature enough. And the simultaneous release is about quality, and we didn't want to introduce immature work. So at the moment, the language that are supported with LSP4E are, I think the best resource is to look at LSP4E documentations, where we try to maintain a list up to date. But most of those languages have their support part of some GitHub projects, and they are not currently in Eclipse Oxygen. Next one, I can do it if you want, Kat.
Sure, go ahead.
The outline does not seem to be synchronized with the editor. Is that correct? I hope it is not correct. The outline is meant to be synchronized. If it's not, you probably know how to report a bug. It's bugs.eclipse.org, and you open a bug and we'll fix it. It's meant to be synchronized actually internally. Lorenzo has this question. So internally, so you know, it's a document listener. So the outline reacts to any change on the document to rebuild itself. So it should be synchronized unless there is a bug.
Okay. And so to go back to Lorenzo's question, I just see here that he did ask, so he was asking preferences that you can change with the preferences dialog. Like you can change the syntax highlighting colors for the Java editor, for example. So not sure if that helps to clarify or if there's anything else to add instead of opening it with generic editor. Looks like.
If it's only about the Textmate part that was demonstrated in the demo I did, not on the one Sopot did, for the Textmate part, Textmate has support for theming, and there are preferences to already tweak the themes. So if you rely on Textmate, it's already there. And I think that if you write your own presentation reconciler, it's up to you to set up the preference you want and to use the preference you want. I believe so.
Yes, that's the case. I think if that's to understand it better, that's a bit one level lower in a way. So you have the power to feed it whatever you want, and then it's up to you to go and pick them up from the preferences or wherever that is, whether it's preferences, whether it's a language server. So the support here is one level below and gives you the flexibility of picking them up from anywhere.
Okay, so was there anything else that Mikhail still put that you needed to add?
No.
Okay, great.
We invite people to just choose those projects to contribute back. Both the generic editor and the LSP 4E are projects which are open to contributions. We are making efforts in making people feel welcome. They are not necessarily easy projects to work on all the time, but they are welcoming. So please join the fun.
Thank you. Okay, so I think that's all the time that we have for today. So again, thank you very much, Mikhail and Sopot. That was a great presentation. Just wanted to provide a quick reminder that our final Eclipse Oxygen webinar will take place tomorrow. So the time is Thursday, June 29th at 10 a.m. Eastern. And that presentation will be covering Eclipse Series 5.0, all about UX, with two of Obeo's finest, Melanie Batz and Stéphane Bogado. And just as always, a final reminder, be sure to subscribe to our channel. Make sure you join the virtual meetup. We are hoping to produce these videos bi-weekly. If you have ideas, send us an email to marketing@eclipse.org, and we will see you tomorrow. Thank you.
Thank you, Kat. Thank you, everyone.
Bye.